So today we're going to talk a little bit about genetic testing. It's too early in the morning to talk about SNP effects and Bayesian algorithms, but we're going to focus a little bit on profit and kind of how genetic testing really relates to the bottom line on dairies. And we've got a lot of really good information now that we've been testing for almost 10 years. And we're starting to see the impacts on some of these dairies, and some interesting insights are being derived from that, and want to share some of that with you today. But first, we're going to start talking about trucks first. I don't know how many of y'all drove here in your farm truck. I'm guessing that more of your trucks look like the one on your right-hand side than the one on the left. But I think all of us probably, just culturally and because of who we are, have some sort of fond appreciation for that pickup on the left, right? The fact that it's still there, it's still running, there's a bit of dependability that's implied just by virtue of it surviving to taking this picture, right? And there's really something about that pickup truck on the left that we appreciate in terms of the value that that brings to us over our lifetimes, or its lifetime, okay? And as I was preparing for the meeting, I was thinking about, where we are in the dairy industry, where we are in thinking about genetic improvement and how we manage animals. And I started thinking about fleet management. It's pretty much the same type of philosophical process here. We have a fleet of pickup trucks in our freestall barns or dry lots, and we've got to manage some turnover cycle. And there are a number of things that are going to inform how we do that, right? What are the ongoing costs of repair and maintenance? What's the value of new features of replacing the new vehicle? And it's getting that balance right and understanding what's the right time to make that switch in our dairy females and replace her with a new crop, but also recognizing what can we do, though, to ensure that more of those look like that red pickup, that they stay a really long time and just provide us with what we understand to be true value to the enterprise, right? It was also interesting, I was on the flight out here reading in the Harvard Business Review, they were talking about efficiency and how we can overdo efficiency in production. And then there was a segment of that article that talked about Wayne Huizenga, and I don't know if y'all know, Wayne Huizenga used to own, I guess, the Florida Marlins and I think the Dolphins at one time, but he started Waste Management, and that was his first business, started driving trash trucks on the south side of Chicago, as I understand. And one of the things that he recognized very early on was how fleet management and managing the turnover of the trucks and how you coordinate maintenance of the trucks was really the key to profitability in waste hauling businesses. And it was through his approach to that, how he precisely managed that, how he created specific territories clustered around service depots that allowed him to grow waste management to what it is today, allowed him to buy many other waste management companies. And it's, again, not terribly dissimilar to what we're talking about here. How do we manage those assets optimally as we think about those dairy females? So if we start focusing on the dairy now, one of my colleagues, Mike Lormore, conducted some research in combination with a financial consulting firm from the upper Midwest. And what they looked at were what some of the key drivers of profitability are on a dairy. And based on their analysis, the key things are, number one, herd replacement cost. As herd replacement cost goes up, it has the largest impact, in this instance, a negative correlation with net farm income. The next three have a positive impact: 21-day pregnancy risk, heifer survival, and energy-corrected milk. So those factors, as they increase, they're going to drive more income. And then finally, somatic cell count, as that goes down, it's going to improve income. And then death loss at the bottom would be the sixth one, also decreasing net income. And so as we think about genetic testing, and we think about the use of genomic technologies as part of a genetic improvement program, we also want to think about them in the context of these key drivers, right? So certainly things that we can do from a genetic testing perspective that positively influence net herd replacement rate or change mortality are going to have a significant impact on what we bring to that dairy financially. This is a graph that I really like. A friend of mine, Dave Galligan, developed this, and we've kind of adapted it here. But one of the things to remember is, and anybody here have a kid in college? a couple of us, right? I have a daughter who turns 21. She's a junior at University of Nebraska. And so I have a very acute appreciation of the maintenance costs of keeping her around, right? At this stage, she's just still accumulating debt, right, for me and my family, which is okay. We like her. But nonetheless, it's kind of a negative cash flow type of situation as it relates to her, right? It's the same situation with our females on the dairy, right? Those heifers are accumulating some amount of debt until she enters into production and we start to recoup that. The time required to recover all of what we've invested into her up until her first freshening, plus her ongoing costs of maintenance, we really need to get to about peak milk in the second lactation on average before she starts to put dollars back into the family's checkbook, okay? So from a genetics perspective, some of the things that we can think about in terms of priorities are, one, what can we do genetically to accelerate that, right? Get her to the point where she's break even a little sooner. But perhaps more importantly, what can we do to maximize her lifetime in that profit-generating portion of her life, right? What can we do to help her stay in the herd longer after she's hit break even? That's really the key to driving additional profitability. We've started to take a look at this in a number of different ways in a lot of different dairies. This is one example we've looked here. This is a Indiana dairy, and we've looked at income over feed costs and correlated that against the genetic potential for milk production, right? And so as you see, there's a very strong correlation here. Animals that have a higher genetic value for milk production, okay, are going to have improved income over feed costs. And that's even after adjusting for the fact that she has to consume more to produce that milk, right? So we see a clear correlation there with a very simple, straightforward trait in milk, right? This is another analysis from Steve Bodart, who formerly at Lookout Ridge, now at Compeer Financial, again, an upper Midwestern dairy financial consulting firm. But what he looked at was in this particular dairy, again, looking at the milk genomic prediction, left to right, from the worst 10% to the best 10%, correlated that against income over feed costs on a per lactation basis, very strong correlation. And based on his calculations in this dairy, okay, a strategy where they use genetic testing to identify the top 80% of females to keep as replacements generated additional profits of $261 per cow per year associated with that selection decision in the first generation. Right? So really good indications from when we look at full financials from these dairies, we can see very clearly that the use of genetic technologies to inform some of these decisions has the potential to really improve profitability. And in this case, it's primarily driving that net herd replacement cost. Okay? But the real gem here, and I suppose maybe the next two slides might be the two that we ask you to remember as you go home today. And for me, this is some really exciting stuff. So we've talked about in all of the livestock industries, the idea of building lifetime economic indexes. We've had net merit dollars, cheese merit dollars, fluid merit dollars for a number of years, our dairy wellness profit dollars that incorporates additional information from our health traits are all examples of lifetime economic indexes designed to describe the difference in predicted lifetime profitability between dairy animals attributed to their genetics. To my knowledge, I don't know that anybody has actually gone back and shown whether or not those indexes actually correlate against lifetime production. I don't know that anybody, I've not been able to find a scientific article that's done that. Well, one of the really fun things we've been doing in the past year is we've been going back to dairies that have been using genetic testing for a long time. And we've gone back retrospectively and said, what if we had dairy wellness profit dollars when that heifer had been born? In some of these herdsmen testing, and we're going to show a couple different herds here, some of these herds have been testing for a number of years. And so those animals have basically lived out their lifetime. We can look at their records and say, what did she actually deliver back to the dairy? How long did she stay? How much milk did she produce? What was her time in milk? And how does that correlate to what we would have predicted her lifetime genetic potential to be when she was just a heifer calf? So on the right-hand side is a pie chart, shows kind of the composition, if you will, of the Dairy Wellness Profit Dollars Index. You know, the real key feature here, it has a lot of the same traits that net merit dollars would and other indexes across milk components, longevity, body composition, udder composition, feet and legs, and repro. But then it also includes mastitis, lameness, metritis, calf traits, et cetera, as part of that index. What the graph on the left shows us in this example, so this is a cohort of 1,000 females, all born in the year 2011, okay, that have been in the herd. We've seen what they've done. They've already delivered it, okay? If we look at their Dairy Wellness Profit Dollars and what that Dairy Wellness Profit Dollars would have been when they were born, we would have predicted that the top 10% would be $1,100 better in lifetime value than the bottom 10%, right? And that's the yellow or orange line here is their average score. What we did was we looked at their actual performance. What did they actually deliver, and calculated her lifetime net present value to the dairy, okay? And again, this is an example where we worked with Dave Galligan, economics professor at University of Pennsylvania College of Veterinary Medicine. So as we look at the actual difference in lifetime net present value, that's these blue bars, we observed an actual difference of $1,700, right? So a couple things here. Number one, very clear correlation between what we calculate to be her lifetime net present value in the dairy based on her genetic profile. And the other thing we see is we predict 1,100, we get 1,700, right? Which, for those of us who look at these numbers all the time, that's reflective of, one, all indexes are inherently conservative in our assumptions. And number two, this is a pretty well-managed dairy that's able to extract all the value out of those animals from a genetic potential perspective. Good management allows these animals to express their genetic potential. So really good evidence here that these lifetime economic indexes do a good job of describing what her actual lifetime profit contribution will be. Now, I appreciate, though, that thinking about lifetime net present values, it's somewhat abstract, right? It's the right way to do it, but it's somewhat abstract. So let's look at another example, and I'll talk our way through this just to make sure the folks in the back can appreciate what we're seeing here. This is another herd, another cohort of about 325 females born in 2011. Here we've ranked them based on their Dairy Wellness Profit Dollars score into quartiles. So the best 25% based on Dairy Wellness Profit are here in the top. The worst 25% are here in the bottom, okay? We see that the difference in average Dairy Wellness Profit, 290 for the top group, 133 for the bottom. And then let's start to see a little bit about what they did. So if we look at the top half here, there are 12 in the top 25%, 10 in the next, so 22 animals that would have been ranked in the top half are still in the herd, okay? Only 3 are still in the herd from that bottom end, right? So longevity playing a big role here. And what does that longevity buy you? Well, there's an extra 40,000 pounds of milk, of lifetime milk in that top 25% versus the bottom 25%. There's an extra 1,600 pounds of fat and 1,200 pounds of protein. And then perhaps the most compelling argument here is those animals in the top 25% spent 30 months in milk versus just 19 in that bottom 25%. And if we roll that all up, average income per cow, nearly $15,000 for that top 15%, and about $8,500 for that bottom 25%. This is really powerful evidence showing us that, hey, these indexes do in fact describe differences in lifetime profitability. the impacts that they have on production, longevity, health, culling, et cetera. All of these things that define whether or not she's going to have a successful career, right? So again, we're continuing to do this work, and we've got a lot of other dairies that are in here, but starting to pull some of this out. And again, to my knowledge, this is the first time we're really looking at these lifetime profitability indexes and how well they correlate back against what she put in the tank and what she delivered. One other study that I wanted to highlight, this is some work that was done at Purdue University. We have one of our dairy production specialists based up in South Dakota, Sioux Falls, South Dakota. He's been doing some work at Purdue in pursuit of his MBA. And what they did was another very similar exercise where they looked at animals that had been in the herd for a long time, determined what their dairy wellness profit dollar score would have been at the time as when they were calves, and then calculated that lifetime net present value. And here what we're showing is if we look at the difference between the average female in this cohort versus the bottom 10%, there's a $1,300 difference in lifetime net present value between the average and the bottom 10%. The difference between the average and the bottom 5% is nearly $2,000, about $1,900 lifetime net present value. So again, lots and lots of examples from multiple herds where we go and look at their actual production and start to really clearly see how big a difference there is in net present value, profitability, and income to the farm from these animals based on their genetic predictions. So, I'm a relatively simple guy, but I threw in a little bit of math. My contention would be that if we think about the fact that animals with a higher dairy wellness profit dollars are delivering more profit to the dairy, right? Clearly what we need to do is just produce more animals that have high dairy wellness profit dollars, right? That's the key. It's a pretty straightforward thing. So the question is, how do I increase that dairy wellness profit dollar score? There are really 4 levers, and this is the beauty of genetics. There's really only 4 things that you can do on a dairy to create genetic improvement. It's not terribly difficult. And for all the complexity of the science, when it comes down to boots on the ground and actually executing, it's quite straightforward. You can decide, who am I going to mate these animals to best complement strengths and address weaknesses, and that's going to create some amount of genetic progress. Right? As John mentioned, there's a lot of good bulls out there, right? So the difference between the choices, right, is going to be a bit less. So we don't see as much genetic progress just simply from mating, but there's certainly benefit there. Semen allocation, deciding how are we going to use sex-sorted semen, how are we going to use beef semen. Those types of decisions are going to create genetic progress if we do that in an informed way. Heifer culling, if we can preferentially keep certain animals, this is one of the strongest selection decisions that we can make, looking at that animal in the bottom 5% and saying, I'm fairly certain on average you're going to provide $1,900 less profit back to my dairy than the average female in this cohort. I'm not going to bother, right? So removing them is a really strong driver of genetic progress. And then finally, the embryo programs. So, and certainly with advances in IVF, the extent to which we use ET in a number of even commercial dairies today, another really key driver, and this is kind of putting your foot on the gas and really driving genetic progress. So those are the 4 levers that you have. How do I want to mate her? What type of semen do I want to breed her to? Do I want to keep her? And how many progeny do I want her to have? That's really the only 4 decisions you have to make. Okay, so keeping it simple is really valuable. Now, for those of you that involved in embryo programs, and particularly when we think about larger commercial dairies that are integrating this into part of their strategy, one of the things that we're able to do is actually not only think about the donor, but also think about the recipient. Okay. Now, intuitively, we might say, okay, we'll find the donor from the top end, and then we'll just take the bottom end and turn them into recips, right? We won't allow her to pollute our gene pool anymore. but I still want to use her reproductive tract to deliver a calf out of that high end, right? But one of the things that we've been able to observe is a key reason why animals end up in the bottom is because their stillbirth values aren't very good, right? You think about stillbirth, the inability to deliver a live calf, that calf has value, that's going to have a significant impact on her ranking, whether we use net merit dollars, dairy wellness profit dollars. It's actually really well reflected in that calving ability metric, okay? This data here shows the percent of calves that were stillbirth across a range of stillbirth PTAs. You see this group here that had a stillbirth PTA of 11, there was 14 of them. 40% of those had a stillbirth. So one of the things we need to think about is, would I ever dare use her as a recipient, right, in an embryo transfer program just because she's on the bottom end? So what I did, excuse me, so I pulled some data. This is an actual cohort of females, tested females. And again, I appreciate that it's small, but we've got kind of all the data here that we might be thinking about looking at. Here's her dairy wellness profit ranking on the left. What I've done is I've flagged the top 2 animals out of this cohort. Those might be our donors. So this first one's got a dairy wellness profit of 1,005. Next one's at 917, right? They're both pretty good across the board. And then I've got kind of the bottom 20 or so here that might be considered as recipients. But what we see pretty quickly, if we look at this daughter stillbirth value, and again, even if we look at this calving ability dollars value, we see there are a number of females here that have stillbirth values of 8 and 9. And so as we think about our embryo program, I would absolutely remove them from consideration as recips. There's no sense in you spending all the money to produce an embryo to stick it in a recip with a 30% chance of having a stillbirth, right? And that's real money. That's really straightforward. So again, using the genetic data throughout the entire population, not only finding those donors, but also identifying the best recipients to make sure that all the effort we go through to create that elite embryo actually results in a live calf. So again, really interesting data. So again, if we kind of go back to our truck example and we think about some of the things that even John mentioned, you know, where we are from a reproductive standpoint in the breed, where we are in terms of the quality of the bulls that are available. We really need to start thinking about reproduction on dairies in terms of asset allocation. The asset is the reproductive tract. And the question is, how do I extract the most dollars from that reproductive tract or that pregnancy as possible in this go-around? And so what you want to weigh is, am I going to be producing a replacement female for my dairy from this reproductive tract? Am I going to be producing a beef cross calf that I might be selling, right? Is it going to be a recipient? It's how do we allocate those pregnancies based on what's going to drive the most value back to the dairy, right? And I think the dairies that are thinking about it in this context are doing pretty amazing things. I'll show you an example here next. So this is a dairy that, it's a rather large dairy. I've pulled some data out of Dairy Comp. I think in this example we've got 1,100 total, or 11,000 total animals. But their strategy is they're using genomic data to identify the top end for donors, and they're pulling recipients out of the bottom end, and then they're using more sex semen in the top half. But the thing that's most impressive to me is 60% of their pregnancies are to Angus semen. Now, I was in the Central Valley in the early 2000s as a young veterinary student. I did my externship at the VMTRC over in Tulare. And so we spent obviously a lot of time working on dairies, looking at records. I mean, you know, at that time, if we were looking at 21-day preg rates of 13, 14%, that was pretty common, right? Think about how far we've come in terms of reproduction, and think about, you know, now really just, I guess I hate to admit how old I am. It's not quite 20 years yet, right? Not quite 20 years, but in 20 years' time, now all of a sudden, we have the ability to allocate 60% of the pregnancies on that dairy to a value-added byproduct calf, right? I never would have imagined that 20 years ago, that you would have that degree of excess pregnancies and the ability to manage a dairy with that type of precision. And so the net result here is they've got 665 live Holstein female calves, and these are largely coming out of their very top end, either through the embryo program or through the use of sex-sorted semen in that top half. So we've created really high-dollar replacement females, only 77 live Holstein male calves, and another 730 Holstein Angus cross calves that would have some additional value, potentially, marketed as feeder cattle. So again, the options that are presented then as you think about how can I allocate each pregnancy to the maximum return, I think for me are really interesting. So what's the process look like? First we need to understand what the needs are. We can't allocate, the worst thing we could do is to allocate these pregnancies in such a way as I don't have enough replacements, right? Because the only thing that's more expensive, or the most expensive thing on a dairy would be an empty free stall, right, or an empty spot at the bunk. We want to make sure that those are optimally used. So we need to make sure we calculate need. That's obviously going to be driven by herd size and replacement rate, age at first calving, heifer losses, either calf mortality or reproductive failure in females are going to be key things there. But we need to calculate that need, and then based on that need, determine how many pregnancies do we have in play. Right? How many pregnancies am I going to need to be able to produce that number of replacements? Once I have that sorted out, then I basically rank these females and allocate according to plan, execute it, and monitor compliance. That monitoring compliance is a really key step. If you go through this whole process and they're not actually allocating the sex semen to the right animals, you haven't really made any improvement other than making the whole process more expensive. So you really want to make sure you have a compliance strategy in place. We have a number of dairy trying to walk through this with them and really looked at a couple different scenarios. So in the first scenario, we've got basically all of our heifers are bred with 1 dose of sex semen. Okay, we're not doing any culling, but other than that, we end up with conventional semen after that. We can see the value of those animals. This kind of shows us genetic progress. The average of our heifers is a little bit higher than our first lactation females, a little bit higher than our second lactation female. So we've got genetic progress going on. But here's the key. As we execute this strategy, we're going to produce 670 replacements with an average predicted net merit dollars of 484. Okay? So we're creating too many heifers in this particular instance, but we're making genetic progress principally through the quality of the bulls that we use, okay? So what we can do is now sit with that dairy and say, all right, what are some options or alternatives that we could use? So the second scenario, what we do is we take the top 70% of heifers, breed them 3 times with sex semen. The bottom 20% don't get any sex semen, just conventional. And then in our first lactation females, 25% of those are going to be allocated to beef semen, and 50% of the second lactation females are going to be allocated to beef semen. Okay? So that's kind of what it looks like once we get it broken up. Now what we've done is we've produced fewer females, fewer Holstein females, 540 of them. But you can see the average genetic quality, we've added $60 in average net merit dollars to that cohort by strategically allocating the technologies and preferentially producing our females out of the higher end, right? So we've right-sized our inventory, no excess, but they're all coming from the right females. So that's an example of how just simply with semen allocation, we're going to create some genetic progress, and we're going to be a little bit more efficient by producing some value-added feeder calves out of that bottom end. The last example we'll look at, this is where we include an embryo program, so the top 2% of heifers go into an embryo program. We're going to pull recips out of the bottom end in these groups using sex semen 3 times in that top 68% or the next 68% or so. That's what that breakout looks like, and the key difference here is we're producing some extra pregnancies out of these donor females. Again, right number of progeny, but we've added a number 128 points of net merit dollars on top of that original approach, what they're currently doing. So kind of shows you the magnitude of the bump. We almost doubled the genetic progress over just the semen allocation strategy by adding the embryo component. So again, I think key takeaways from what we've talked about today, the first thing is we're really starting to get some very good data about how these indexes work on farm and how they correlate with actual lifetime profit. And so I think one of the things I'd ask you to take home is as you look at those economic indexes and you look at that Dairy Wellness Profit Dollars Index, it's pretty capable at identifying those females that do in fact have greater profit potential on farm based on real world data. Okay? So that's point number one. The second point is thinking about as a dairy producer, you have a number of levers at your disposal to use to try to maximize genetic progress and manage your genetic program in a way that creates additional profit. How are we using embryos? How are we using beef semen? How are we using sex-sorted semen, et cetera? Okay. And then finally, I think, thinking about rather than historically just getting cows pregnant and not kind of worrying about, the process, do it the same way all the time, maybe stepping back and thinking about each pregnancy as an asset and how would you allocate technologies optimally to derive the most value out of that pregnancy? Because they don't all need to produce Holstein replacements. And I'm really pleased to know we're going to talk a little bit about beef dairy crosses here a little bit later today, because I think that fits really well here. Not all of them should be producing Holstein replacements. Not all of them are good enough to do it. All right, the key is we need to find which ones are capable of doing it, preferentially allocate the technologies to them to get the job done, and then sit back and let them go to work. So with that, again, appreciate your time and attention this morning. We're awful excited about the things that we're doing in our business. We recognize it's been a difficult year for the dairy economy, and certainly appreciate your business as part of that. At the same time, if you look at genetic testing growth in terms of sample volume, more heifers were tested last year, a lot more heifers were tested last year than the year before. And using genetic testing as a way to try to help identify ways to put more profit into the dairy, ways to generate some cash flow if you can remove that excess batch of heifers off without sacrificing the future of the dairy. A lot of producers are very fully invested in it. And we really think it's a technology that fits well even when times are tough.